Well, what we want to do in this lesson is to construct this shape here. And afterwards, we can find the area of the shape constructed. Alright, so this shape is, what kind of shape it is though? It's a four-sided shape, meaning it's quadrilateral, means four-sided shape, but only one pair of sides parallel. These are the two sides that are parallel, and that's the only pair. The other opposite sides are not parallel. So this makes it a trapezium. Americans refer to it as a trapezoid, right? So let us now see how we're going to construct this. Well, as usual, we need our base. So let's draw a straight line here. We want it to be longer than 7 centimeters. And then I'm going to go at point inwards for A. And of course, we want it to be longer than 1. Well, no, not longer, sorry. We want it to be as long as 7 centimeters. Okay, so that will be, let's double check. Make sure that is exactly what we want. Right, so this will be just a little bit off. It's good to get it as accurate as we possibly can. Okay, so that's good. I'm going to grab an arc here. Go at the end of the intersection. Grab an arc this way. And so where the arc intersect the lines, we have our A and our B. And this will be B. Now the thing is, we want to construct a 90-degree angle here, so we can do that quickly. So we can change the radius distance of the compass, right? I want to ensure that it's smaller than the piece of line that's extended after A to the left. So I can create a nice semicircle here. Alright, so this is going to be 180 degrees. Right, from this end to this end is an angle of 180 degrees semicircle. So I want to bisect this 180. So I go at both ends where the intersection took place. So right here, I can change my compass distance. So right at the intersection of the arc and the straight line, I'll scribe an arc here. I'll go to the other end where we have the other intersection. I'll scribe an arc as well, maintaining the same radius distance as we did for here. That part is important. And then I'm going to draw a line going through A and through the intersection here. Now the thing is, it may look like it's not 90 degrees, but remember, I drew this line anyhow, so this line will be 90 degrees to it, depending on whether or not I did it accurately. So let's see. Zero line, center of the protractor. You can clearly see that it's 90, right? 90 degrees. My zero line is on 0 with this line. Alright, so I have my 90. Now I only want what? 5 centimeters up. But before we do that, let's okay. Well, it doesn't really matter. We can improvise. We can say, okay, we can construct the 45 here and just draw a long enough line, or we can get the 5 up, and then we create a 90 degrees angle going. All right. So let's do this side first. We want 5 centimeters up, right? Where would 5 centimeters be? So we can use a ruler for in fact and just see that that's going to be 5 centimeters. The important thing is that we're not using our protractor to create those angles. Alright, so we can measure off that. That's 5, right? Alright, so that's our 5. How we choose to do this, whether we put it on it like that, measure it on the ruler, and then go like this, and it's fine. I don't think it's a big deal though, because you can use a ruler and just measure it. Use a pencil and describe that. Okay, so that's 5. So this point here is our point what? D. And next, what we really need, we need the right angle created right at D, based on this. So we did a right angle at D that extend outwards. So let's see if we can do that. So I'm gonna just change this paper around so that I can actually get this angle to be 90 degrees, a line that will pass through D at 90 degrees to this line. So I'll go here. All right, I'm gonna go here at D and create a semicircle at D. All right, where intersection meets that line. I think I need to just double check this. Okay, so I have that. This end look a little crappy, so let me just double check that. Okay, it's good. It's good. Okay, so I can change the radius distance now, but I have to maintain it on both sides. So I'll go here, grab an arc, maintain that radius distance. I go here, grab an arc, and where the intersection took place, I'm going to draw a line through D. Alright. So let's look at what we have here. So this is 5 centimeters. And I was just double check to make sure, yes, we did that. It's 5 centimeters. This angle is 90 degrees. That's constructed. And this line here is 7 centimeters. But what we need now is what? A 45-degree angle that will go and meet this line up here. So we can determine what length of DC is. So create our 45-degree angle. What we can do, we can create the 90 first and bisect the 90 to get 45. So let's see, we create the 90. Again, remember what we did. There are two ways to construct the 90. We could create a 60 and 120 and bisect that 60 and 120 to get the 90. But this is much faster. So we're going to go to both ends. Now we can change the radius distance. Go to this end. Grab an arc. Go to this end. Grab an arc. And then I'm going to draw a line through this so I can get my 90, but we really don't need that 90, right? It's just that we need to use it to get our 45. So this is my 90-degree line to this one. This line is 90 degrees to this line. They're perpendicular, meaning meet at 90 degrees. Now think of this angle here. Well, this is 90 degrees, but think of this arc here as cutting these two legs of the angle 90 degrees. So I can go at both ends where this arc meets this leg and grab an arc and change the radius distance when I'm grabbing arc outwards. But I'm not going to change it when I go to the other end. I'm going to maintain that same distance there. I'm going to draw a line through the intersection. Now these should be clear, so whoever is marking can actually see these construction lines. When I say clear, it must be quite visible, clearly shown. I'm going to draw a line through this point, intersection of the arcs and B. And so this is where this line, which is 45 degrees, meets this line here. So this is where we'll put what? Our C. Okay, so if we look at it, this is a trapezium. We have A, B, C, D. So we can now measure our DC, see how long that is, and I get 2 centimeters. So DC is 2 centimeters. Now of course we can find the area easily, right? Well, to find the area, we know it's going to be what? Half times A. These are the 2 parallel sides, so they can consider this to be my A and this is my side B. The 2 parallel sides. Alright, the 2 parallel sides are A and or B. Doesn't matter which one is which in terms of A and B, because we're adding, right? Out of addition doesn't matter. So now AB, DC, let's call it our A. We measure that to be what? 2 centimeters. I'm going to add B, which will be this side, since they're the 2 parallel sides, 7 centimeters. Multiply by the perpendicular height, which was measured at 5 centimeters. And so we're going to get half. 2 plus 7 is 9. And centimeters plus centimeters give us more centimeters. Multiply by 5 centimeters. 5 times 9 is 45, so it's half of 45 centimeters squared. And that's give us 22.5 centimeters squared. Alright, so some other things you could do. I mean they typically probably would not give this, but you never know if they would. But let's say if you want to find the area, I don't remember to use this formula. Probably could actually divide this up into rectangle. Well, a rectangle and a what? Triangle. So we have this piece here, rectangle, and this side, this piece here, or a triangle. But notice that we got a right angle out of it. Now, if from here, this is 2, right? This is 2 centimeters here. From D to C, 2 centimeters. So that's 2 centimeters. So that means this here, down here, let's see where this is that. Since this is 2 centimeters from D to C, then from here to here will also be 2 centimeters. See why? And this part here will be what? From there to there will be 5 centimeters. While from here to here is 2. So in finding the area of the rectangle, it's going to be what? 5 times 2, which is 5 centimeters times 2 centimeters, which gives us 10 centimeters squared. And the area of the right angle triangle, let's see what that is. Remember, this has a height of what? 5, so this has a height of 5. And the base is 7. So the area is going to be what? Half times the base, which is 7. Well, not 7, but 5. The whole thing here is 7. But we'll take out the 2 from it, we're left back with 5. So the base of this triangle is 5 units. So it's half times 5 centimeters times the height, which is what? Also 5 centimeters. Let's give us 5 5 is 25. Half 25 is 20. Half 25 is 12.5. So when we add the area of the rectangle, which is 10, to the area of the triangle, which is 12.5, and add them together to get the area of the trapezium, we get 22.5. Same answer. Hopefully that was helpful. Now again, the perhaps would never ask these questions when we have to do construction. But I just cut this up into 2 parts, rectangle and triangle, to show you some concepts that you probably might find useful.